On to section 3 of chapter 3. Now, we've done a lot of work with simultaneous equations, systems of equations in two variables. We're now going to use some of that technique to solve word problems. And we're going to total value problems, total mixture problems, and motion problems. So what we'll do here is go through the strategy step by step. Now, I don't know if you saw that extra one I did on section 1.7 for up to 2 bonus points if you take some good notes. This one is part of our class, so you don't get any extra credit for it. But if you want to master the material, this is a good place to do it. So let's take a look at it here. Maya sells concessions at a local sporting event. In 1 hour, she sells 72 drinks. The drink sizes are small, which she sells for $2 each, and large, which she sells for $3 each. If her total sales revenue was $190, how many of each size did she sell? So this is very, very typical of a word problem in which we could use two variables. So I read it very slowly, but let's underline the key things. That she sells, that's not important. In 1 hour, that may or may not be important. But here she sells 72 drinks. That's the total number of drinks she sells, okay? And there's a small size at this cost and a large size at this cost. So again, we have to translate that into algebra. And I think a good beginning would be to say we have small, and we can use the letter S for that, and large, and we can use the letter L for that. Now you can think of this as an X and a Y if you'd like, and in fact I think that's probably the letters they will be using later. Okay, now do we know how many small? Nope. Do we know how many large? No. But we know together the small plus the large will equal 72. Does that make sense? That was the total number of drinks, and there's two types. Okay, now how much does the small drink cost? Well, $2 times the small drinks plus $3 for the large drinks will bring in now how much money? $190. And there are your two equations. So again, what method might you use? Well, remember, we could use, oh, I think I just lost everything here. Hit the wrong button. Okay, so here we are again. If we multiply each term in this equation by, let's say, a -2, here we will have a -2. 2s plus negative, well, we don't want a plus there, we want a negative there, negative 2l equals a negative 144. So now when we copy equation 2 underneath it, so when we do our subtraction, this column cancels out. Here I'm left with an L, and I'm subtracting 144 from 90, so I get 46. I subtract 46 from 72, and I get 26. So what is your answer statement then? Well, Maya sold 26 small drinks and 46 large drinks. So once again, here's the total drinks. The two sizes equal the total. $2 for the small, $3 for the large. This is your total income. There are your two questions, or two equations. So I then multiplied the top one by a negative 2 each term. That allows me to cancel out the s's through elimination, and there's my answer. Okay, let's check it out. So we read it slowly, got an idea of what we could label the drinks, and here again they're using S and L, that's good. And there basically is your first equation here, and your second equation there. There's the first, there's the second, and now we solve. Now we could have used, and I see they use, or are going to use, substitution. They solve for the letter L. That's good, because we did it the other way. Let's see what they get for an answer. Again, they get for the small number of drinks, 26, and for the large, once we subtract, 46. So again, we used elimination, we got 46. Here they're showing us through substitution. And it all checks out. We're not using a graphing calculator to do it, but that would be your point of intersection. And there's a check. Okay, let's take a look at this next one. Now again, the key to these, as you do them in your practice and later quiz me, do it slowly. You want to understand the problem. You want to work it. So here again, we're dealing with cookware this time. And there are two sizes, okay, of pizza stones. The circular stone sells for 26, rectangular for 34. In 1 month, she sold this many stones, and she made this much money. How many of each size did she sell? Well, this one is very similar to the one we've done. So here we have circular plus rectangular stones. And how many did she sell altogether? 37. Now, what's the cost of the circular? 26. And the others, 34. And she took in this much money. So again, this one is just the same actually, except we had used different items here, a small and a large drink. Here's circular, rectangular, total numbers of stones sold. Here's the cost of the circular, cost of the rectangular, and that'll give you a total amount of money. So again, this could be done by probably, well, I don't know, we could use substitution. But again, just to show you the difference, I'm going to multiply this by what? So that one of these will cancel out. A negative 26. So as I do my new equation, I get a negative 26C minus a negative 26R equals, now I paused it so I could use my calculator a little bit. A negative 26 times this gives me a negative 962. But then I got what I'm looking for. I'm able to cancel these out. This one I get an 8R, and this I get a 176. Divide both sides by 8. I get R is 22. Well, if R is 22, what will C be? Well, I just subtract 22 from 37 and I get 15. So once again, what's your answer statement? Well, she sells 22 rectangular stones and 15 circular stones. Here, the use of the letter R and C are useful in identifying which product you're dealing with. Okay. So again, something very similar. There's our first equation. Putting it in a chart may be helpful. There's your second equation there. And you could use substitution as well. Going to solve for one of these letters. And, oh, they're going to use elimination this time also. Okay. Could have used substitution. And 8R equals 176. R is 22. And we substitute 22 for the R in our first equation. And we get 15 for C. Perfect. And you could have done it with a graphing calculator as well. And it checks out. Okay, here's our next type of example. And let's see if we can underline what we think is important as we go along. Coffee shop, considering a new mixture. All right, these are going to be mixture problems. They're going to create an Italian roast that's going to cost this per pound. Now to do this, we're going to mix Venezuelan beans that cost this per pound. And the types will be mixed with 60-pound batch that sells for this per pound. How many pounds of each type should be made to get the blend? Okay. Well, we know we're going to get a 60-pound batch out of this. So let's see what letters we can use. We're going to use roast blend. All right, well, let's use the R from the roast beans. That's the R from the roast beans, plus the blend of the blend beans. And we're going to end up with 60 pounds of this. That's going to be our N amount, 60 pounds. Now, what does the roast blend cost per pound? Well, that cost 9 point. My pen was giving me a little bit of a hard time there. So again, there's the roast, there's the blend. We want 60 pounds of it. Now the roast costs this much per pound. Again, this is similar to the ones we've done. The other is this much per pound. And then you're going to put something in the middle, so it costs more than this but less than that. And you're going to have 60 pounds of it. And there's your equation. Okay, now you can use substitution. Here probably is the better one because we have some decimals. Now remember, you can do this to the decimals. Just multiply every term by 100, and then you get rid of all the decimals. No more decimals, okay? The answer is going to come out the same. So there's our basic chart if you want to set it up. This is going to be the 1050 times 60 is this. So you can write it as that as well. Okay, and they're going to use, I believe, substitution. There they substituted. They didn't get rid of the decimals. Okay, that's another way to do it. I think it's easier if you get rid of the decimals. So we see we're going to need, for the Italian, I guess, and the Venezuelan is the letters they're using, you need this much and this much. And I believe it checks out. Okay, now we're going to do something else, which is a mixture problem, similar to what we've just done. But again, you want to watch it carefully because if you have a mixture problem, this is what you'll need to know. And let's look at it carefully here. So a cleaning company wishes to mix cleaner that is 30% acid and another that's 50% acid to get a mixture that is 35%. So 30's there, 50's there. We want something toward the middle. Mix some of this with some of this. And we want to end up with 20 liters. So again, we can use X and Y, by the way. X will be our 30%. Y will be our 50%. And the amount of 30% plus the amount of 50% will be 20 liters. There's our first equation. Very similar to what we've done before. Now, what's the acidity in the 30%? Well, it's 0.30 X, and in the 50%, it's 0.50 of Y, and you're going to end up with a 35% mixture of 20 altogether. And you could actually do this multiplication. That's what they're going to have done. Again, I would get rid of the decimals by multiplying every term by 100. And I believe they're going to use substitution. Now you could use elimination, by multiplying this equation, every term, by a negative 30. Then these will cancel out, okay? Well, we want to see the diagram here. I like that. So here you have 30%, here you have 50%. You want to get something in the middle or toward the middle. How much of each? This is where the algebra is beautiful for this. Just set it up like we did. So here they're just giving us another example here. So there's our x and y. X is 30, y is 50, and we want to have 20 of this. So there's our basic equation. And they're doing elimination. Good. They've kept the decimals, which I don't think is a good idea, but again, you could. And they're saying we will need t, that they're identifying as the 30, is the 15 liters. And the other one is 5 liters. Okay. T is the 30, F is the 50. We're already at 21 minutes, so we're making this a little bit tedious and long, but again, lots of stuff going on here. Okay, we've done some of these before, but we're going to go back to distance, motion problems. Distance equals rate times time, and rate is distance divided by time, and time is distance divided by rate. And there are all three of them. So if we solve for r, we just divide both sides by t. If we're solving for t, we divide both sides by r. And from this one, we can generate the other two. Okay, two cars leave Toledo at the same time traveling in opposite directions. One car travels at 60 miles per hour and the other at 45 miles per hour. In how many hours will they be this far apart? Well, let's use what the book has too. I think that's good. Make a drawing. Okay. Now there's the distance they're going to be apart. One's going this way at 45, one's going this way at 60. Now, what do you know about the time here? Well, in this case, the time is going to be the same for both of them, right? So what was time? Time, you recall, was, so if we use this formula, again, our basic formula is distance equals rate times time. So the time is going to be the same for both cars. So rate times time plus rate times time is going to equal the total distance. Rate times time, so 45t plus 60t equals 225. So in how many hours will they be apart? You just have to find what t is here. There's our formula, and we'll solve it. Add like terms, divide both sides by 105, and our answer then is 15/7. And by the way, if you want to put that in a mixed number format, 7 goes into there twice, 2 1/7 hours is your answer statement. And it does check. Again, the use of the diagonal bar, bad. Make it nice, horizontal. Okay, now let's check this one out. Because of a tailwind, a jet is able to fly this many miles per hour faster than another jet going into the wind. That slows you down. The wind's on your back, you move faster. In the same time it takes the jet to travel 90, the second jet only travels 80. How fast is each jet traveling? Okay. Again, a picture is good. And it's, again, distance equals rate times time. And again, what's the same in both cases here now, since time is the same for both of them, we could put a second letter here, T and T. So actually but that's not going to work out too well. So what is T? Well, we said T was distance divided by rate. Well, we know the distance and we know the rate. So this is going to be then 80 divided by R, and this one is going to be 90 divided by R plus 20. And we know that time equals time here. So this will be one part of the equation, and this will be the other part of the equation. So let's go on. And there we go. Now, a shortcut when we have something like this in solving it is to do what we call cross multiplication. We're going to multiply 9 times 90 and get 90R equals 80R plus 1600. Now we're going to solve for our rate. Subtract 80 from both sides. We get 10R equals 1600. Divide both sides by 10. R is 160. So what are the rates? Well, this one is 160, and the faster plane goes 180. And those are our answer statements. And there we got R equals 160, but we have to know the other one too. And it does check out. So the slower plane was 160. The faster plane was 180. Okay, here's a little summary too that might be useful. We're approaching 30 minutes here. Draw a diagram, organize the information in the chart, look for time, distance, or rates. What are the same? These can lead to an equation. Translate the system, and sometimes you can use two variables. These last few we're doing with just one. Always make sure that you answer the question that was asked. And that'll wrap this up.